Hello and welcome back to this PHP mini course where I teach you some of the fundamental theories and practices of PHP. In today's video, I want to quickly go over object-oriented programming inside of PHP. This is something that you should get a grasp of before going into the further tutorials that I will be providing, as I will be using object-oriented PHP to create my applications. So, what is object-oriented programming then, or OOP? Object-oriented programming is a coding approach that structures programs around objects. Objects being instances of classes that combine both data and actions. You'll understand it when we start writing it. So, how is object-oriented programming used within the PHP ecosystem? In PHP, object-oriented programming is used to build structured, reusable, and scalable applications. It's widely applied in web development frameworks like Laravel, where classes and objects represent controllers, models, and services. Object-oriented programming in PHP allows developers to organize code into logical units, making larger projects easier to maintain and extend. It's also used for creating APIs, libraries, and plugins, as well as managing user systems, database integrations, and backend logic. Overall, PHP's object-oriented programming features help developers write cleaner, more modular code that mirrors real-world entities and simplifies complex web applications. Now, that's enough talking. I think it's easier to just show you what it is, how it looks like, and how you can utilize it. As mentioned before, object-oriented programming works around classes. To create a class, you use the class keyword, followed by an identifier name. So let's do person as an example. Inside, we can then add methods and properties. Methods are functions inside of the class, and properties are variables inside. For example, like it gives me here, ID. A person can have an ID. A person can have a name. A person can have a last name. Now, what we can then do is create a person. So let's say Mike is a new person. Now what we can do with Mike is using this arrow operator, which is a new operator if you've never done object-oriented programming inside of PHP. This pretty much lets us access the methods and properties of the class. So for example, ID. We can give it an ID of 0, a name of Mike, and a last name of John. Now, I don't know if anyone does have John as a last name. If you do, welcome. But we've got Mike John. So now, Mike, the object Mike, is a person that has an ID of 0, a name of Mike, and a last name of John. Think of it as like bundling information together. And all of these properties belong to our person, Mike. This means if we were to print them, let's say Mike ID, Mike name, and Mike last name. If we head on over to our PHP application, oh sorry, we're still on the previous form, we can see 0, Mike, and John. Now with PHP, you can also do something like this, where you can actually print out the whole class itself by just saying Mike. Now it gives me a warning. This is because you can't convert a person to a string. This is due to the echo function. If we use something like print R, now we should be able to print out this, and it gives us a little bit more information. You can see it's a person, that is an object, it has an ID of 0, a name of Mike, and a last name of John. Now, you might have noticed that we use this word public before. Usually when we define a variable, we don't usually use public, do we? We just do this. But we have an error now. Unexpected token ID. Every time you create a property or a method, which we'll get onto in a second, you need to add a visibility specifier. Or an access modifier, sorry, not a visibility specifier. There are 3 access modifiers. Public, which as you can see we have just now used, private, and protected. Now, you might already notice that down here we now get an error. Member has protected visibility and is not accessible from the current context. Now, what does this mean? Well, these words do actually mean something. They're not just random syntactical sugar. Public says this method or property is accessible publicly, which means anyone could write code like this on our object to get that data. Let's say we make it private. All of a sudden we can't. We are not allowed to view or edit this data because it's private. The only person or the only thing that can edit this ID is something inside of this class. And then finally we have protected. Protected, similar to private, but it also means that the property is accessible inside of the class and its subclasses. Now we'll get onto that in a second. First, let's go over methods. So I'm going to quickly go and change it to private, our ID. Now, let's say we want to edit our ID. This is where we can use a method. Usually, when you've got values or properties inside of an object, you don't really want to be able to just access them. You want to run functions to edit them. I'm going to make a function called public set ID, which will take an ID. Whoops. And we'll set this ID to the ID we got in our variable. Now, why is this? Unexpected token. Sorry. Function. This is a function. Methods of functions. So, public function set ID. This is also called a setter or a setter function, where the user can specify an ID, and this will change this ID to the ID the user specified. Now, you might notice this. It's also highlighted in red, but it's not an error. No, like it says here, this is a special kind of variable. It's a reference to the calling object, which means when you have this, when you write $this with this arrow, which is something you might have seen before, it means access anything inside of this class. It's specifically saying that we want to access something in this class. If I put this, you can see we get our ID, our last name, our name, as they all belong to this class, but we also get set ID, the function, because it also belongs to this class. Now, we are unable to do something like this anymore, where we say $Mike ID is 0. Instead, we have to manually set it using our setter function. So, this is where we do Mike, arrow set ID, and we can set the ID to whatever we want, like 1, 2, 3. Now, if we go back here and reload the page, we can see that our ID is 1, 2, 3. You've also noticed, most likely, is that our print R also gives us our ID and specifies that it is from our person class and it's private, which means obviously this is a private variable. Now, what happens if we do protected? It'll give us protected. It says protected. For debugging purposes, you can then check what kind of variable it is with this print R. Pretty cool. Anyways, that's how we would then be able to change and modify a private variable. Is inside of a function inside of our class. Alright, so moving on, I want to talk about constructors and destructors. A constructor is a function that is ran on the creation of the object. If you're wondering when that happens, it is right here. For our person object, we create a new person. This tells us that we're creating a new object. And you see we added these parentheses, like a function. But why? Well, this is where something like a constructor comes in. At the moment, we don't have a constructor, so we leave this empty. And if we try to put something in it, it'll give us a warning. So, let's add a constructor. I'm going to get rid of this function for now, as we won't need it anymore. But I'll keep the properties, and I'll make them private. So now, as you can see, our code below fails. It no longer works. This is where we use something like a constructor. This is how you would write one. You say public function, as it is a function. But instead now, you put 2 underscores, and called construct. And any code you write inside this block will be executed as soon as the object is created. Inside of this construct, we can add parameters, such as our ID, name, and last name. So when we create the object, we put it in here. So I'm going to put an ID, a last name, and we put name first actually, sorry, name, just like that. And like before, we can run something like this. Thank you, autocomplete. But we put this because we want to access our private variable here, and we set it to whatever we put in our parameters. So this code is now irrelevant, but we see we get a warning now saying we're missing an argument. So we'll put an ID of 1, name of John, last name of Smith. All of a sudden the warning's gone, and if I run this code again, as you can see, everything just works perfectly. And for each one of our variables or properties, we get a private because they are private properties now, which means we cannot access them outside. As you can see, the IntelliSense just gives us a constructor. Obviously, you shouldn't really be doing this, but that's it. This is all to do with class safety, pretty much. You don't want people to access the properties inside of the class. But they should always be private, in my opinion. But some people do put them public. And a constructor is like an initial setter. Like we had a set ID before. Imagine this as a setter, but for everything. And this is how you would do it. Obviously, you can run whatever you want in here. You can run an echo, like, hello world, I am a person. And this code will now be printed, as you can see here, because the class is created. Even when I get rid of this print R, it gets printed. Now, another thing we didn't talk about was destruction, or a destructor. I'm guessing you can figure out what that can mean. But think of it as a constructor, but the other way around. You don't really want to put any things or any parameters into a destructor. A destructor is called automatically when the variable or our object is out of scope, or gets deleted manually, or something else happens. But usually when the object just gets removed. So let's say here, echo, person destruction. And when I reload this page, we get person destruction, as well as our constructor. Now, when does this get called? Well, it is technically right after, because we have no code afterwards. If I was to put an echo of hello after our person and rerun our application, you can see we get hello world, I am a person, hello, and then person destruction, because person destruction occurs at the end of this file. So imagine there's some invisible line here, just deleting it. So what if we want to delete now an object before this hello echo? We would use the unset function inside of PHP and pass in our mic variable, as this is what holds our object. So if we go back to our application and reload, you can see hello world, I am a person, then person destruction is called, and then hello. Pretty much, if I put this in comments, our constructor is called here, our destructor is called here, and then we print here. I hope you get the gist. Now, what I want to go over now is inheritance. Inheritance is pretty much where a class extends another class to reuse or override behavior. So, let's say we create two classes. This is going to be quite a simple example, quite a common example. We have a class of animal, which has a public function of speak, where we could just echo sound. And we can have another class, such as dog, which extends animal. What this means here is now whatever is inside of our animal class is also accessible through our dog class. Let me give you an example. Let's create a dog. So we'll do dog is equal to a new dog. And now all of a sudden, what we can do is we can do dog.speak. Even though inside of the dog class, we don't have a speak function, but that is because we have one in here. So if I go back here, we get sound. Now this means that we can kind of separate functionality in a way, or have the same functionality through multiple classes. If I create a class of cat that extends animal, our cat can also speak. So now we get two sounds. But what if I want the cat to make a different noise? Well, this is where we get to do function overriding, where we could do something like this. What we're doing here is we're just overwriting the function. As you can see, something showed up here in our animal class, one override, because our cat class that extends our animal class is overriding the speak functionality. If we go back to our application, now we get meow instead of sound. Now we can still access our previous speak function using this parent with 2 colons and then speak. This allows us to reference our parent class and call specifically any method inside of that. So what will happen now is we should get sound meow. It's getting a little bit confusing. Let me just get rid of the dog for now. But we get sound and meow. This is due to this. It's pretty much like saying now, animal, speak. Pretty much the same thing. Now here's a really good example of where we can use our access modifiers again. So here we've got a public, but let's say I make it private. All of a sudden this doesn't work because we can't access it because private, this function only belongs to this animal class, which means our dog speak also doesn't work anymore. Now what if I change it to protected? All of a sudden, we don't seem to be struggling here, or here, sorry. We can call parent speak, but we can't call it here. And if you remember what we talked about, protected means this function is only accessible inside of the class itself or any of the subclasses, the cat and the dog. But we can't call it externally, like we're trying to do here. So therefore, if I quickly comment this out and run our cat speak, we can get sound and meow, because we're able to call it here. This is where access modifiers become quite important. You can store some data that you want to share between subclasses in a different class, but you don't want someone to access it. Here we're printing out sound, but we could have some other special functionality that we only want accessible behind the scenes in the class. This is where something like this is very useful. Another key concept is abstraction. Abstract classes. To define an abstract class, you pretty much start off with abstract, followed by class, followed by whatever. Now we have an abstract class. Now, an abstract class pretty much is to define a base structure for another class, but it cannot be initialized. What this means is that we can't go here and type in shape is equal to new shape. This just doesn't work anymore. If you get rid of abstract, we can. But you cannot create an instance of an abstract class. But what you can do is use it as like a template. Abstract, public, function, area, as a shape example. Now if I have shape that extends, class square that extends our shape, you will notice we get an error. And this is not because we can't extend abstract classes. This is because class square does not implement abstract methods, public function area. If there's an abstract function inside of an abstract class, and a class inherits that, it needs to override it, create its own instance, create an implementation of that class. Luckily with VS Code we can do a quick fix. Oh, what? I have to pay to do that. Unbelievable. Alright, let's run it ourselves. This is where we have to write a public function area and put our own logic, like return this dot width, this width times this height. Obviously we need to quickly create these variables, so just bear with me. Width is going to be 10, height is also going to be 10 because it's a square. Well, that just sounds a bit silly now, because we could just do one variable, whatever. But we can create a square. Whoops, new square. And this works. And we can run square.area. But as soon as we get rid of this area function, we get an error inside of our class because we need to implement it. This kind of puts us onto the next topic, which is quite similar, which is interfaces. Interfaces, similar like abstracted classes, from what we learned so far, define a set of method requirements that any implementation classes must provide. So a very similar thing you'll see here. You can create an interface. Let's say shape2 for now. Public function area. If I now, instead of extending it, I use implement shape2, the logic would be the same. The class square does not implement abstract methods function area. So why would I want to use interfaces and why would I want to use abstract classes? This is where the difference comes in. Abstract classes are used when multiple related classes should share common code and structure, but still need to override or complete certain methods. Interfaces are used when unrelated classes should follow the same method contract to ensure consistent behavior across different implementations. So I'll give you this example, our previous animals. If we create an abstract class for our animal, we can give it a public name, a constructor which will set the name. And then we can create an abstract function to speak. So now, let's say we create a dog. We still get the same warning. We need to implement the speak function. So we create a public function, speak, which will override the speak function above. And here we can run something like this. Return this name. Because this code here now works like as if it's part of the dog class. This means inside of here, when we create a new dog, I need to run a constructor with our name, even though we don't have a constructor in here. So I can have something like Johnny, and I can get the dog name, even though it's not defined inside of our class dog. It's defined inside of our animal. And of course, I can also run speak, because it now exists. This is where abstract classes come in very handy. Because as you can see, if I do an interface example, I can only write functions. Sorry, let me do something like this so it doesn't fail. I can only do functions. I can't set a name. I can't set a public name. That's not allowed. Interfaces only let you create function structure. So therefore, this is used anytime you create a function, for example. Let's just do a bit of this. Let's say I have a function out here that says runs animal functions, and it takes in an animal that's the type of animal too. This means any animal passed in here is expected to have whatever functions are in here. So this can be, like we have here, we have animal speak. And let's do another one, animal eat. Let me just add this here. Just like that. Now, if we create our dog, and run our runs animal functions, passing our dog, it doesn't work because we don't have these functions. And what even if we do? We technically still don't, because we don't implement the interface. So this is where, hold on a second, let me just implement our animal to interface. Obviously now we can't get a this.name anymore because that's not shared functionality between the classes, which means that I need to actually give it a name. And I also need to give it a function to eat. So that's just going to be echo eat. Okay. Actually, to be fair, I think I might just echo this instead. Just like that. Okay, so now dog is able to be passed in here. But we can create another class. So I'm just going to duplicate that, but just call it cat, which implements the same thing. But now it says eating meow. So I say this name for speak, whatever. But I can give it a name of like Mikey. And I can create a cat now. So I create a cat, new cat, and give it a name of Catty. We can now pass in cat in here as well. Even though they are two different objects, this one might have an extra function, like dog might have poo. It still will work because it implements the interface and it has the functions necessary so that this function can run those functions. This is where interfaces come in, very useful. So use an abstract class if you need shared common code and structure and some methods that need to be overridden, and use interfaces to define a clear structure or a definite rule that this function has this method. And the last thing I want to cover for classes is static members. Static members pretty much means that whatever the member is, it belongs to the class itself, not the instance. So you can call functions without initializing a class pretty much. Let me show you. If I have a class of math and I create a public function add, which obviously takes an x and a y, and just returns, yeah, let's do that. I need to create an instance of this math class, something like this, to then run, our function. Get the result and echo result. So then if we, that's my OBS. If I go back here, the result gets printed. It just seems a bit silly, doesn't it? That I need to create this math object to then use the add function. This is where static members come in very handy. If I change this to be public static, all of a sudden, yes, this works, because I can still create an instance of it, but I don't need to. I can write something like this. If I rerun this, it works. This is because this function belongs to the class, not to the instance. You can also use it on variables. Public static name. I know hello is not really a good name, but I can then do math name or $name, and it works. Stuff like this is great if you're working with helper or utility methods. Don't use static if the method needs to access something inside of the object, like when we use the $this. So something like this, we have our add function in our math class. This is perfectly acceptable, and you'll definitely see it used here and about. Anyways, that's it for classes and object-oriented programming inside of PHP. I hope that you were able to understand everything and learn about object-oriented programming inside of PHP. In the following videos within this course, we will be utilizing object-oriented programming with web applications, and you'll see how that works. So make sure you leave a like and subscribe so you won't miss the next videos, where we really put object-oriented programming to use in a real-world environment.